chapter 5, we're going to continue with probabilities, but before we get into probabilities, we need to discuss what is called random variables and probability distributions. So first off, we're going to talk about random variables. Random variables are a quantitative variable. If you recall, we have talked about quantitative and qualitative. Quantitative means it's numerical. So it's a quantitative variable x is a random variable if the value that x takes on in a given experiment or observation is a chance or random outcome. So here's some examples of random variables. The number of eggs in a robin's nest, measuring daily rainfall in inches, counting the number of defective light bulbs, measuring the weight of a polar bear cub. Now, random variables can be one of two types, and those are listed here. One of those is called discrete and one is called continuous. Discrete can only take on a finite number of values, meaning it's countable. So how many are there? There are 0 chairs, 1 chair, 2 chair, 3 chair. Continuous can take on any countless number of values in a line interval. So think of a line interval. So if you had 0, 1, 2, 3, countable is only 0, 1, 2, 3. Continuous means it could take on any value in between. It could be a half, it could be 1 3/4, it could be 2 1/4, it could be 3.11111. So continuous means it could take on any value in between. Oops, be helpful if I move that up, sorry. And just the reason it's continuous is because we know there are infinite numbers in between two values. So when we look at our random variables up here, we want to be able to distinguish which of these are discrete and which of these are continuous. So if we look at discrete, which means it takes on countable, then the ones that would fall into that would be the number of eggs in a robin's nest, and then the number of defective bulbs in a case. And the examples of continuous would be the daily rainfall, and that's because when it rains you don't just get 1 inch or 2 inches, you could get 1.5 inches, so it can fall in between two values. And the other would be the weight of the polar bear cub. Now, sometimes scales will just show, like if you got on a scale, it might just show 125 pounds, but as we know, if it was more exact, you could weigh 125.2 pounds. So weight can be continuous as well. Now, one of the things you'll be asked in assignments and on a test is to be able to distinguish what type of a random variable. Now, it may not tell you, or it may not ask, are the following discrete or continuous. It may just say what type of random variable are the following. When you see random variables, you need to know that it's asking you, is it discrete or is it continuous? These two words may not be given, but you need to know that when it talks about random variables. So we have 4 examples here. So the time it takes to complete an exam. So is that discrete or continuous? That would be an example of continuous, because it might take you 42.3 minutes or 42 1/3 minute or something. So it is continuous. The number of bad checks written in a day, that would be discrete. Nobody writes 1.5 bad checks. Amount of gas in a vehicle, that would be continuous. Number of registered voters in the district, that would be discrete. There aren't 3.5 registered voters. It'd be 3 or 4 or 5 and so forth. So there's an example of your random variables and the type of random variables. Then we get into probability distribution. That up there. This is an assignment of probabilities, and please recall that probabilities have to be a number between 0 and 1 to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. Probabilities for each random variable x. So basically what that is saying is for every random variable x, you're going to find its probability. That's what that's basically saying. Now, to be a probability distribution for a discrete random variable, so in this we're only talking about discrete, not continuous, there is a probability assigned to each value, and the sum of all the assigned probabilities must equal 1. That's the other characteristic we have to remember. All right, so here's a table that represents a discrete random variable. So x is my discrete random variable, and that is the number of appliances sold on a given day. So this x, this would mean we sold 0 appliances, 1 appliance, all the way up to 7 appliances on any given day. F is the frequency or the number of days that many appliances were sold. So this means there were 9 days that we sold 0 appliances, 72 days we sold 1 appliance, and so forth. So we have to assign a probability to each of these. So we want to know, what is the probability that when I go into work, I sell 0 appliances? Well, if you recall, probability, we do F over N. So that's your relative frequency. So favorable would be your F. Your N would need to be the total number of days in which this was recorded. So we're going to sum up this column right here, and that equals 240. So the probability of 0 would be 9 days out of 240 that occurred. I'm going to go ahead and convert these into decimals just because it makes it a little bit easier. And I am going to round to 2 decimal places, but in WebAssign you might need to be a little careful with this. Be sure and pay attention to what the directions say. So, and I'm going to use normal rounding rules. So 0.04, the probability of selling 1 appliance would be 72 over 240, which is 0.3. The probability of 2 would be 63 over 240. And I'm rounding to 2 decimals, so I'll put 0.30. 0.26. The probability of 3 would be 41 over 240, which is 0.17. The probability of 4 appliances would be 28 over 240, which is 0.12. The probability of 5 is 14 over 240, which is 0.06. The probability of 6 appliances would be 8 over 240, which would be 0.03, and the probability of selling 7 appliances is 5 over 240, which is 0.02. So if you recall, this kind of goes back to chapter 2 where we did relative frequencies. So if we look up here, the sum of all the sum of all the assigned probabilities must equal 1. So that means when I add up this column, this summation should equal 1. Now in this case it does, but again we did some rounding, so sometimes it might be 0.99 or 1.01 or something like that. So be careful of that. All right, so now that we have this probability distribution, we can answer some probability questions. It says, find the probability that 6 appliances are sold on a given day. So the probability that we sell 6 appliances is 0.03. So when it says explain, if I were to explain this, then I would state it in sentence form, and I would say the probability of selling 6 appliances on a given day is, and I'm going to go ahead and convert that into a percent when I do an explanation, just because people can relate to that a little bit easier. So the probability of selling 6 appliances on a given day is 3%. So, moving on. Find the probability 2 to 5 appliances are sold on a given day. So 2 to 5 means the probability that 2 to 5, and we could sell 2 or 5, so I'm going to put equal. So this means the probability that you sell 2 appliances, or 3 appliances, or 4 appliances, or 5 appliances. And notice or, so I'm going to add. So all I do is go up to my probability distribution, and I find the probability of 2 was 0.26. The probability of 3 was 0.17. The probability of 4 was 0.12. And the probability of 5 was 0.06. I add all of those together, and I get 0.61. So there is a 61% likelihood of selling 2 to 5 appliances on a given day. And that would be my explain. Now I have another probability question, but it's on the next page, so I'm still going to be referring to this probability distribution. And it says, find the probability at most 2 appliances are sold on a given day. At most 2 would mean 2 or fewer. Be careful with that. At most is kind of a tricky one. So 2 or fewer would be that X is less than or equal to 2. So that would include 0 appliances, 1 appliance, or 2 appliances. So going back to my probability distribution table, the probability of 0 appliances was 0.04, 1 was 0.30, and 2 was 0.26, and you add all of those up and you get 0.6, and 0.6 is 60%. So there is a 60% chance of selling at most 2 appliances on a given day. All right, now what we're going to do is we're going to look at how to graph the probability distribution. So here is my probability distribution, this right here. We're going to look at how to graph this. So it says put the probability on the vertical axis and the random variable on the horizontal axis. So I'm going to create my vertical and my horizontal, and it says the probability goes on the vertical. So I look at my probabilities. Here's my P of X, here's all my probabilities, and my largest is 0.30. So I'm going to go 0.05, 0.10, 0.15, 0.20, 0.25, 0.30. and then the random variables on the horizontal axis, and our random variable is appliances sold. It's very important to label and label correctly. And we had 0, 1, 2, 3, 4, 5, 6, 7. The bars will touch, so that tells me I have a histogram. The height of the bar is the probability, and then title and label. We've labeled our axes, but we'll have to title. So I'm going to go back, and each one of these, this will be the height of their bar. So for 0, we have 0.04. And then we have 0.30. So this goes way up here. Trying to make these straight. 0.26. 0.17. And that's why I put the number on top of the bar, because we don't have graph paper, so that way I might be a little off, but people will know what I'm trying to graph. 0.12. 0.06. 0.03. And 0.02. And then I need to title, which might be appliances sold per day. Now, if you knew the name of the store, like Sears or whatnot, you'd want to add that, but we weren't given that. Now, this is a histogram. Do you remember we talked about the different distribution shapes of the histogram? We had symmetrical, uniform or rectangular, skewed left, skewed right, and bimodal. So if I asked what is the distribution shape of this particular graph, well, this one's pretty obvious. It goes off to the right, so this would be skewed right. All right, now we're going to get into some calculations that are a little bit more involved. And that is when we're asked to find the mean and the standard deviation from a probability distribution. Now, the mean is the expected value. So in that, what I'm saying is, based upon this data, when you walk into work, how many appliances do you expect to sell? I don't expect to sell 7 every day. That doesn't happen very often. I want to look at the likelihood and say, how many would I expect to sell? When I look at this, I go, 0.3, 0.26, 0.17, here are my highest likelihoods. So I'm going to guess it's somewhere in 1 to 3, somewhere in there. That's what I would expect, but we're going to actually calculate it. So anytime you see the word expected, you know it's asking you to calculate the mean. Well, here's the formula for how to do that. The mean is equal to the summation of x times p of x. The standard deviation, as you can see, this is a little bit more involved formula. It's the square root of the summation of x minus mu squared times p of x. We're going to do a couple of these problems so you'll be able to see how this works. All right, so using the appliances probability distribution, this says find the expected number of appliances sold in one day. Well, as soon as you see that word expected, you know it's asking you to calculate the mean. Well, I'm going to rewrite that formula up here since it's on the other page. That formula is the summation of x times p of x. So what we need to do is we need to calculate x times p of x for each x value. So we had 0, 1, 2, 3, 4, 5, 6, 7, and then we're going to multiply them times each of their probabilities. And P of x, that would be these numbers right here. So we had 0.04, 0.30, 0.26, 0.17, 0.12, 0.06, 0.03, and 0.02. So we're going to multiply each one of these. And when we do, that gives us 0, 0.3, 0.52, 0.51, 0.48, 0.3, 0.18, and 0.14. So we've multiplied every x value times its p of x. So what we have done is this portion of the formula. Now what we're going to do is find its summation. So you're going to add all of these numbers up, and when you add those up, you get 2.43. So what we have found is that the mean is 2.43 appliances. So on any given day, I expect to sell 2.43 appliances. Well, that's kind of comical because you're not going to sell a part of an appliance. But in your homework, it'll probably ask what is the mean, and this is what you would give as 2.43. But if we were explaining this, we would say on any given day, I expect to sell 2 to 3 appliances. Because you can't sell part of an appliance. Now again, on WebAssign, it's probably going to ask what is the mean, and you'll put 2.43. But if you were asked to explain your answer, then you would give something similar to this. So that involves some calculations. Well, guess what? We're now going to do the standard deviation, and that calculation is even a little bit more involved. So just a reminder of the formula. Standard deviation is the square root of the summation of x minus mu squared times p of x. So what we're going to deal with first is just this x minus mu squared times p of x. So this is where it takes a lot of calculations. So we're going to do x minus mu, and mu is what we just calculated up here is 2.43 squared times p of x. We have to do this for each x value. So we're going to have 0 minus 2.43 squared times 0.04. 1 minus 2.43 squared times 0.30. 2 minus 2.43 squared times 0.26. 3 minus 2.43 squared times 0.17. 4 minus 2.43 squared times 0.12. 5 minus 2.43 squared times 0.06. 6 minus 2.43 squared times 0.03. And 7 minus 2.43 squared times 0.02. Now, when I do these calculations, I'm going to show you how to put it into the calculator, because we're just going to put it into the calculator once and hit equals. And it's pretty simple. So here I would do open parentheses, 0 minus 2.43, close parentheses, hit the squared button, times 0.04, and then hit enter. Now, I'm going to go ahead and round to 2 decimal places. Again, be careful on WebAssign. Sometimes it'll ask you to go further out than that, but for notes, I'm going to go out to 2 decimal places, so that would be 0.24. All right, I'm going to do one more on the calculator, and then I'm just going to fill in and put the answers on the rest of them, but be sure you know how to put it into your calculator. So open parentheses, 1 minus 2.43, close parentheses, squared, times 0.3 or 0.30 equals, and that would be 0.61. And then the next one is 0.05, 0.06, 0.3, 0.4, 0.38, 0.43. All right, so we've done all of that calculation. Now it tells me to take its summation. So now what we're going to do is we're going to add this column. And when you add this column, you get 2.43. Now, where a lot of students make their error is they say this is the standard deviation. What they forget to do then is you have to take the square root of that summation. It's very easy to forget, so be very careful. So the standard deviation is the square root of 2.43, or I'm sorry, this is 2.47. 2.47. I was looking at this 4.3. 2.47. So the standard deviation is 1.57. So here's my standard deviation. Here is my mean. So I expect to sell that many appliances when I go in on any given day, but of course it can deviate above and below 1.57. Okay, we're going to look at one more example to get you familiar with this. Plus, the table looks just slightly different. So in case you encounter one like this, I want to be sure you know how to handle it. Okay, are we influenced to buy a product by an ad we saw on TV? The National Infomercial Marketing Association determined the number of times buyers of a product watched a TV infomercial before purchasing the product. The results are shown as. Okay, so this means a consumer watched the infomercial once, and 20% of the time then it purchased the product. Another buyer, they watched an infomercial twice, 31% of the time then. After that, they then purchased. So this was 3 times the infomercial, 4 times, and then 5 times. Now, here's the biggest difference. On the last probability distribution that we did, this is done horizontally where this table is done vertically. Same thing though. Here, we had to calculate the probability. We had to do F over N. For this example, we're not going to have to do that. This percent is in essence your probability. So the probability of each of these is just converting that percentage into a decimal. So this is actually a lot easier. I don't have to figure out the probability. It was already done for me. So then it says find the expected number of times buyers watched a TV infomercial before purchasing, an expected number that tells me I'm going to find the mean, and then it also wants me to find the standard deviation. So the first thing that we're going to do is find the mean. So what we need to do first is take x times p of x So we're going to have, oops, I about put 0. 1 times 0.27, 2 times 0.31, 3 times 0.18, 4 times 0.09, and then 5 times 0.15. So we're going to multiply each one of these. Again, I'm going to round to 2 decimal places. 0.27, 0.62, 0.54, 0.36, 0.75, and the mean is the summation. So if you add all of these up, you get 2.54. That's very similar to the last example. So the mean is 2.54, which tells me if I were asked to explain this, then I expect buyers to watch an infomercial two to 3 times before purchasing. So now what we're going to do is find the standard deviation. So now we have to do x minus mu squared times p of x. So we're going to have 1 minus 2.54 squared, and here's where I'm getting the 2.54, times 0.27, 2 minus 2.54 squared times 0.31, 3 minus 2.54 squared times 0.18, 4 minus 2.54 squared times 0.09, 5 minus 2.54 squared times 0.15. Now, I'll just do another one of these on the calculator just to remind you. So, turning this on, I would do open parentheses, 1 minus 2.54 close parentheses squared times 0.27, and I'm going to round to 2 decimal places, so 0.64. So I'm going to do that for each one of them, and this is 0.09, 0.04, 0.19, and 0.91. Now we're going to find its summation, which is 1.87, and this is where you need to be careful. This is not my standard deviation. I am not done yet. To find the standard deviation, you have to take the square root of 1.87. So the standard deviation is 1.37. Double check that. So the square root of 1.87, whoops, need to get out from under the radical. Did not like that. Oh, sorry. Square root of 1.87, there we go, 1.37. So it was correct. So there is how to find the mean and the standard deviation. Definitely one of the longer calculations that we have to do throughout the semester.